Okay, is our next contestant ready to go? All mic'd up, fantastic. Thank you so much, that was brilliant. 2 fantastic talks so far. Next up we have got Stephen Moreland, who is going to be talking about visualizing plasma. So this talk is about explaining what plasma is, what goes on inside it, why it's so interesting, why it's useful, and how to help make it as easy to visualize as any solid, liquid or gas. So please give a very warm welcome to Stephen Moreland.
What do you think of when you hear the word plasma? Can you visualize it? Anyone who's played Halo knows how overpowered it is when used as a sword. If you owned a swanky flat-screen TV in the late 2000s, chances are it was plasma. But what is it? If I ask you to visualize a solid, liquid, or gas, you could do it, right? I mean, it doesn't look like there'd be much problem visualizing a liquid tonight. But why not plasma? I mean, it's the next step, a bonus 4th state of matter, and it only makes up a measly 99.9% of the universe. Now, we know the particles are held together by nuclear forces, and if we apply heat energy, then they can overcome these forces. In a gas, they can expand as far as they need to completely fill whatever container they're in. So where do we go from there? What forces are left to overcome? Well, if we crank the heat up to 11, then we can separate electrons from their atoms, and then we're left with a big bowl of positively charged ion soup, but instead of croutons floating about, we have a generous portion of electrons. It is the most disconnected and chaotic form that matter can exist in. And inside it is like a huge speed dating event. Billions of single electrons whizzing about, not wasting any time, going up to the first one they see, "Are you single?" And sometimes they get rejected. "Oh, you're sweet, but I'm actually here with my nucleus. Thank you, though." But they're like a gentleman, and they leave them alone. "That's okay, have a nice day." And they run along to the next one they see, "Are you single?" "Yes." Bam, they're married. And they live happily ever after on an atomic energy level. But sometimes one of the electrons isn't very happy. It wants to spend some time with another electron on a different energy level, and they get divorced. Well, that'll stay on then. They get divorced, and one of them moves away. Now, in plasma, billions of these rejections, marriages, and divorces happen every second, each creating their own unique radiation pattern, and they all combine together to form a huge energy spectrum all the way up to X-rays. Now, that's just one scientifically unemployed physicist definition, because like so much in the modern world, plasma is really hard to define. It's a bit of a diva. The phase transitions we know that get us from certainly a solid to definitely a liquid to absolutely a gas, there isn't one for plasma. Experts are still trying to pinpoint when the switch happens with rules like how many electrons per cubic centimeter does it need, or how many neutral particles are allowed, or how much force can a charged particle feel from another charged particle. But there will never be a easy rule to distinguish them. No Ned Flanders cider rule. If it's clear and yellow, you've got highly ionized gas there, fella. If it's tangy and brown, you're in plasma town. But I'm of the scientific opinion that who cares what something is, as long as it does something useful. Now, my speciality in plasma came from a literature review that led me down a rabbit hole where I eventually accepted plasma as the all-powerful God and the answer to all of science's problems. If you think of anything physicsy, I promise you, I'd wager a strong bet that plasma plays a role in the research. Astrophysics, particle accelerators, and the big kahuna, fusion research, all plasma. So hopefully I've made it easier. Can you visualize plasma? Thank you very much.
Brilliant. Okay, love the voices there. That was
some of them landed, some of them didn't.
That's the risk you take. It was very, very good. Okay, so Aaron, our resident physicist, you want to start with the question?
Hello there. So, bit biased. I am a solar physicist, so I love plasma as well, but astrophysical plasma. The sun is a ball of plasma. Slightly biased. What did lead you? You said it was your literature review. Was this during a master's then, or what led you to then going? Plasma is the coolest or hottest, I guess, in some circumstances.
I got my third choice master's project at Queen's last year, and it was on like developing this really cheap form of diagnosing plasma emissions, like being able to. So like a proper spectroscopy thing would cost like hundreds of thousands of pounds. We built one that you could make really cheap. And then from that, I sort of got really into plasma. I didn't really know what I wanted to do until my 4th year, but then I kind of realized, plasma kind of is pretty cool. It does a lot of things, and not many people know about it, even though it's the 4th state of matter. So I just kind of wanted to do my talk on that, I guess.
Biggest thing I can relate to there. I got my 9th choice of master's project, so...
And my friend Ryan got his 7th, and you were his PhD student.
I was.
Okay, fantastic. Do we have another question?
Well, you mentioned we don't know how plasma transitions through different states. Why do we need to know that?
Well, it's just because they're so defined for solids, liquids, and gases, and I don't really think we need because there's never going to be a distinct point. But I guess it's just since, as I mentioned, it's 99.9% of the universe, so it's kind of confusing. Why don't we know exactly what it is? So it's just it's an interesting, as I said, it's like a diva. It's not, we don't really know what it is, so it's I'm not really sure how to answer that anymore, but I tried my best.
No, it was very good. So it's a good answer. It's the Beyonce of matter, which is fantastic. It is a diva. I love it. Thank you so much. That was brilliant. A brilliant way of making a very complicated subject funny and also interesting. So big round of applause for Stephen. All right.